Hi, I'm Sam Roberts from Roberts Geospatial Engineering. Today I'm going to take a quick look at the GEBCO 2025 version of their Terrain and Bathymetry global dataset. So here's the GEBCO website. Down here you'll find the grids that you can download, their geotiffs and so forth. But a better thing to do is to go to the Roberts Geospatial Engineering website, go to the Resources tab and then Data, and down here you'll find GEBCO 2025. Now you can download this file in MRR format. It's a 6.6 gigabyte file. It contains 4 datasets. It's got the ice surface elevation, that's the top surface. It's got the sub-ice topography and bathymetry, so that's the bottom surface underneath the ice in Greenland and Antarctica. It has an ice thickness channel, which is just the top surface minus the bottom surface, and it also contains the type identifier grid, which I've turned into a classified raster so that you can visualize in each cell where they acquired the data from. So to view this data in MRR format, you will require ProRaster. ProRaster comes in 3 versions: ProRaster Essential, when my internet catches up, Essential, Premium, and Scientific. So you go to the Microsoft Store, search for ProRaster, and you'll find these products. You can download and install the software for a 7-day free trial. At the end of that, there's no obligation, but that will get you started. You'll be able to download that data and take a look at GEBCO 2025. So let's do that now. So I've got ProRaster Scientific running here. I'll just drag and drop that file into ProRaster Scientific. So we're going to look firstly at the top surface. Going to come in here and change the color scale to the Atlas color scale, which ships with ProRaster. And just going to change the layer name to top surface so we know what we're working with. Going to add a layer for the bottom surface. So let's come into bottom RL. Need to change that intensity as well. Again, I'll use that color table for Atlas. Come and change that name. We'll call that bottom surface. Going to add another layer. Oops. From that recent raster, so GEBCO again. This time I'm going to use ice thickness. So that's the 3rd band in the first field. There is a second field which we'll look at as well. Ice thickness. I want the same color scale. We're going to compare these, so I want the shadow scaling to be common across those 3 layers. So I'm going to override this statistical factor and turn that off. So we'll go with that. And then we'll just add in a layer. Actually, I'm going to need an image layer. I'm going to choose GEBCO 25. I'm going to go for the second field, which is the ID field. I'm going to use the class color, and there's a type ID raster. Change this to type identifier. Okay. So we'll come across here, and now I'm going to go into map flipping. So here's our top surface. Flip again, we go to the bottom surface, and you can see that in Antarctica is the ice has been removed, and in Greenland the ice has been removed. Here's our ice thickness band. So we have positive values over Greenland and over Antarctica, and there's some other data up around in Russia and in northern Canada. And here's the type identifier, and this is a per pixel classified raster, which tells you, so if I come into my tooltip here, it will tell me, oh, that's I need to select this. Anyway, it doesn't matter. It'll tell us what the class is in each of the cells and where the data actually came from. Turn that off for the time being. So there's the 4 data bands that we ship in that file. Let's take a look at the, let me come in here, I'll bring this across so you can see what I'm doing. I'm going into the algorithm, and then I'm going to select, say, the Northern Hemisphere projection. Here it is. Perhaps we'll zoom in a little bit. It does take a little while to reproject as we zoom in, and also it's rendering all 4 bands so that we can do grid flipping. So we're looking at the top surface there. If we flip now to the bottom surface, you can see that that ice cap on Greenland disappears. Here's our ice thickness. So now you can see that that additional sort of almost looks like noise. So we're getting some from northern Canada, and over here, I can't point with my finger, I need to point with the nails, some data from northern Russia. So that's the northern hemisphere. Let's go to the southern hemisphere. I'll just choose the south pole. So I'm changing the projection, the coordinate system of the map. So now we're looking at Antarctica. So there's the top surface with the Antarctic ice cap. There's the bottom surface, and it's just catching up, rendering at a higher resolution. There's the ice thickness, and here's our type identifier data. Ice thickness, bottom surface, top surface. So you can explore that data in ProRaster Scientific. I just want to do a little comparison between earlier GEBCO datasets. They put out a new dataset every year. So we'll do a comparison of 2022 with 2025. I just happen to have 22 sitting around. So, oops. So here's 2022. This is old 2022. We'll change that color to our Atlas color table. And then I'll drag and drop in 2025 as a new layer. So this is new 2025. Again, come in, change that color table. Oops. Again, go in and control the shadow globally because I want everything to be perfectly comparable. So now we can go in and do some swapping. So I'm going to flip here, and we can see if there's been changes from 2022 to 2025. So if I flip back and forth, you're probably going to find it very difficult to see any difference. But I can see quite clearly some areas where there's been significant changes. So for example, up here, I can see some changes. There's more seafloor topography there. Some quite substantial differences in here and in here, both in the bathymetry and something odd going on there, both in the bathymetry and in the land. The thing about GEBCO dataset is that every year things change. And some things get better and then some things get worse. So here we've got some new noise introduced in 2025. Indeed, all of these coastlines look degraded in the 2025 compared to 2022. They've become more blocky. So there's some problems there, I reckon, up in that sort of Canadian region. But going elsewhere, you can see improvements. So if we come here between in the Bass Strait, there's the old data 2022, and you can see there's these ship track artifacts, and they've cleaned that up for 2025. Coming up the east coast here, there's new high resolution data, which is good. And then there's other things. So for example, here we've seen a degradation. We've got high resolution here data in 2022, and in 2025 it disappears. And this is the story of GEBCO. They take one step forward and two steps back, or perhaps two steps forward and one step back. But things certainly get better and worse simultaneously with every release. So what about out here? So out here, so there's the new, old, new, old, new. So you can see that there's new coverage out here of high resolution, probably multi-beam sonar. So that's good. Improvements out there. So in general, I'd say it's an improved data set. But as always, there are problems. And what I'd say to GEBCO is do yourself a favor, go to the Microsoft Store, download a copy of ProRaster Essential for $30 and get a work experience student to take a look at your data and do some QA. And then you'll see the differences. You can see them very easily. It's taken me like 3 seconds to find the differences between the 22 and the 25 data, and to identify problems that should have been picked up before the data was published. So that's my advice to GEBCO. Otherwise, go to my website, get the data, get the software, start exploring, and you'll really appreciate this fabulous data set that they update every single year. Thanks for watching.